Alrighty, welcome back. Did you guys have a good fall break? It's nice. Okay. Did you catch up? Did you get a chance to take a break? I definitely liked it. I'm glad that they introduced fall break. I think it gives everybody a chance to kind of refresh, catch up, and things. And now we're looking at the next. You only have today. This is week 9 of the semester, so you have about 7 or 7 weeks, depending how long you count on it. About 6 weeks left of the semester, so let's finish the semester strong. So the next few weeks we're going to be continue to talk about the back end, and then around week 12 we're going to have the second midterm, and then after the second midterm the lectures are more special topics, and there are topics to help you complete your final project. So after week 12 you're going to be spending the next 4 weeks or so after that working on your final project, and you're going to have little milestones to help you progress on your final project. So we're pretty much at the half point of the semester, a little past it, but stay with me just for a few more weeks, and you'll be done. So let's continue our journey into the back end of this class. Today I will be sharing the midterms at the end of the class. So we do have a lecture today. So at the end of the class, I will go over the midterm solutions with you, and I'll also pass them out. I'm also giving back your cheat sheets. If you are curious, last night I did post this is the stats. All right, so the average between, I was kind of surprised to see the average between this section and the 4 p.m. your afternoon section, they're about the same. So I was very pleased to see that. Typically, I always want to know, like, the smaller classes mean better performance, because my 4 p.m. class is double this class size. So anyway, the median is pretty close to the average. The standard deviation is really high, which is very typical for programming related classes, because unfortunately in programming a lot of time it's like you know it or you don't. So there's a lot of big variance usually. Like we usually have like A's and then like C's and D's. Like it's usually spread apart. But we did give as much partial credit as possible. So I didn't graph it here. So distribution is not too crazy. It's actually yeah. Anyway, so that's the average. So overall, everyone did a pretty good job. This is the highest average I've ever seen for this class, and this is the 4th semester we've taught it. Usually the average has been between 75 or so, 75, 76 or so. So this is by far the highest. So good job overall. And there some people are asking, is there a curve? No, there is no curve. I don't curve anything in this class. There's no Marshall curve here or anything like that. Everything is raw score here. So whatever you get is whatever it is. The only exception is if, let's say, the average was really low, like a 60 or below a 70 or something like that, then that's the only time I would curve, but this is fine. And this is a good time, if you haven't already, to go on Blackboard and check your weighted total. That column is the percentage, is your approximate current grade right now. The only grade that's not available right now on Blackboard are, remember you get 3 free absences in this class. Those absences don't get dropped until the end of the semester. So there's that going for you. Assignment 6 is still not, it's almost done graded, but it's not complete quite yet. So you won't see that reflected on your weighted total yet. So besides those 2 things, it's pretty accurate. So it's a good idea to go check. This is week 9, right? So next week is I believe next week is the drop deadline, or is it this week? So you want to, make sure you're on track. For those of you that are concerned with your grade, feel free to come talk to me. We can discuss more detail about where your grade is currently. I do want to remind you there's a second midterm, and the second midterm is worth the same as this midterm. So if you feel like you didn't do such a good job on this midterm, there is a second opportunity to raise that midterm. There's my grading breakdown. So the midterm is worth 25%, meaning this one is worth half of that. And so the second one will be worth half of 25% as well. So there's that. And then the very last thing is the final project. The final project is a pretty big chunk of your grade. It is that one project is worth 30% of your grade. So again, if you feel like you want to raise your grade, you do have the opportunity at the final project. There is going to be one last extra credit opportunity for those that have asked. It is the final project. If you choose to present your project, you get extra credit. So for the day of the presentations, everybody must come be in attendance because that's our final exam. But if you want to present, it's actually going to be optional. If you do present, you get extra credit. So there's one opportunity for extra credit, and that's it. So here's kind of a clear roadmap for you to think about where your grade is going. And also we have a few more assignments and a few more labs as well. So keep that into account as well. Okay. All right. Let us talk about stuff today. Let us talk about SQL today, and then at the end of the class, I'll go and review the midterms. So if you can please, let's go ahead and do some to-dos here. We are going to create a brand new database. So last week, before fall break, you created your own database. We talked about how to design databases. This week, we're going to be talking, now that we covered how databases kind of are designed and some terminology, we talked about relationships, we talked about like primary key, foreign key, and all that stuff. Now let's go ahead and interact with the database. Let's write some SQL. We're going to be writing something called SQL to interact with the database, meaning we're going to be able to now grab data from the database. We're going to be able to search through databases. And to make this a worthwhile lecture, I have given you a much bigger database than we've been used to before. I'm going to give you this database called the Song database. And the Song database, as you can imagine, has like tracks, has artists, albums, and all this stuff which we're going to be working with. And we're going to be writing some SQL statements to grab data out of this ginormous Song database. So if you can please, let's do a few setup things before we get started. Let's go ahead and first of all, we have to create a brand new database. So let's go ahead and go over to our cPanel once more. If you're wondering what the cPanel is, by the way, the cPanel is another piece of software, and it helps us. It gives us a nice user interface to do things on the web server itself. So not all servers come with this, but we've installed cPanel for you guys so you could interact with the server without having to run terminal or anything like that. So anyway, this is like a friendly way for us to interact with the database. So on the ITP Web Dev server, after you log in, this is all your stuff here. So let's go ahead and click on MySQL Databases, like we've done before. And let's create another database, and we're going to go ahead and import data in here. Let's give it a second. Okay, let's create a brand new database right over here, and we're going to just call it song_db. Right? We're going to continue to use that lowercase underscore convention, and I'm going to create database. There you go back. And then if I scroll down, there it is. You should see in current databases, if you scroll down, you should see Song database. Perhaps you have the restaurants database still, and the film one that we made last time too. Let's do, but we're looking for this one here. Okay, while we're here, I know we haven't done much with the user stuff yet, but we will next week. So while we're here, after you create the database, let's scroll down, and we're gonna add that user back to where it says add to user database. We're going to add the DB user that we created last time. We're going to add it to our Song DB here. We're going to go ahead and add. Okay, and just give them all privileges. And then if you scroll down go back to that current database section, you should see the Song database that was just created, and it says assigned to my DB user. Okay, if you missed any of this step, let me do this one more time with you. Go ahead and go to 303itpwebdev.com/cPanel. All right, and then we're going to click on MySQL databases like we've done before, and we're going to create a brand new database so we can work with this one. Create a new database. Go ahead and type in SongDB, and notice how it already prefixes it for you here. All right, you're going to go ahead and create database, and then it should show up. If you scroll down, it should show up under current databases. You should see now your username Song database, and then assign the user to it. And currently it's 0 bytes, meaning it's an empty database, but we're going to go ahead and fill that up. All right, once you have this database set up, we're going to go ahead and we need to fill up this data. And instead of us writing all the stuff for it, I'm just going to give you a script that just fills up our database. Go ahead and download this back to the lecture notes. Go ahead and download the SQL file, song.sql. We're going to go ahead and download this. Okay, I'm going to go ahead and just save it somewhere. Just save it somewhere that you remember. I'll just save it in my ITP 303 folder as usual. Maybe call it lecture 13 today. Okay, there's my song.sql file right there. Right, once you've downloaded, let's go back to the C panel, go back to the home of the C panel here, and we are going to use phpMyAdmin. Let's go and click this, phpMyAdmin. And you've seen phpMyAdmin briefly, but phpMyAdmin is simply another piece of software. It's a very friendly user interface that allows us to take a look at our databases. It's kind of similar to MySQL Workbench, but the only difference is that phpMyAdmin is installed directly on the web server. Unlike MySQL Workbench, it's actually installed on your computer, but we're connecting to the server, right? So there's a slight difference here. phpMyAdmin, once you get to phpMyAdmin, we're going to go ahead and click on, hopefully you see the song database right now. And you're going to see that it's empty because we haven't put anything in there yet. All right, one more time, if you missed this step, we're going to go back to C panel. We're going to click on phpMyAdmin, and it's going to open a new tab, this phpMyAdmin. phpMyAdmin is another user interface that allows us to interact with the database. It's very nice to use. It's a very commonly used piece of software. Right. Once you're at phpMyAdmin, click on Nyan SongDB, and we have this database here. We're going to click on, where is it? Import right over here. Okay, so we're gonna make sure you're selecting this one, or else it's going to import to the wrong database. So again, click on your song database, click on import. We're going to click choose file, and that file that we're choosing is the file I just downloaded, the song.sql file. Song.sql, we're going to go ahead and open. All right, and then we are going to click go. Awesome. Hopefully you see this. Import has been successfully finished. And then hopefully on the left side, now you're going to see the song database is populated with all these tables. So we have all these tables now. And if you're kind of curious, go ahead and click on the tracks table. If you click on the tracks table, you're going to see we have a bunch of tracks. These are a bunch of songs. And warning, giving you a fair warning right now, these are pretty old songs. So that's why you actually see unit price here. This is like kind of meant to replicate the iTunes database. So this is how much it used to cost. There's like, there's track ID. We're familiar with that, right? The primary key. There's the name of the track. Oh, and then there's like album ID, media type ID, genre ID. We've seen that before, right? These are foreign keys. They map to different tables. Here's composer, milliseconds, and so on and so forth. Okay, so you can kind of click around. There's like a genre table for all the genres of songs. It's taking a while. There you go. There's all the genres. There's a primary key again. The genre ID is a primary key, and then we have name as well. And you can also see there's also a table called invoices and invoiced items. So this database was also tracking if people were purchasing songs, and they were tracking like invoices and tracking like who bought. Or I think we have the customers as well, like who bought what. And so there's a lot of information in this database. But for our purposes, we're gonna keep things simple. We're only gonna and I kind of have a screenshot here for you. The thing that we're gonna care about is just these tables here: tracks table, artists, albums, media types, and genres. So this is the design of the database. This is the diagram of the database. This helps us kind of visualize how all the tables are connected together, what kind of relationships they have. So we start at the tracks table, right? Tracks table is kind of like our main one. Tracks as in like song tracks. right? We have track ID as a primary key. We have the name, so on, composer, so on and so forth. And then this is interesting. It's a little bit different than how I would design a database probably, but this is how they're doing this. So instead of mapping tracks directly to artists, they're kind of mapping it out like this. So they're saying each track has one album, right? So they're kind of thinking in terms of songs are in an album, like a CD, in a CD album or whatever it is, in an album. Okay, and then for each album there is an artist. So the way songs get mapped to artists is not like it's not a one-to-one relationship or anything like that. It actually goes through albums. So one artist can have many albums, right? And then albums can have many tracks, but tracks can only be in one album. Album can only have one artist. So this, I guess, this design is also not covering cases like where we have multiple artists for one album, right? So it's not really covering that quite well, but there it is. All right, so and then we also have a one-to-many relationship with media types to tracks. So media type meaning like is it an MP4 file? Like what kind of format is it? Genre is hopefully straightforward. What kind of song is it? Is it pop song, jazz, R&B, rock, so on and so forth. So there's a one-to-many relationship with genre as well. Okay, so having a diagram like this is pretty useful when you first get a database and you don't understand the relationship very well. Having a diagram like this is very useful. And in a development world, in the industry, this is very typical. You just get handed a database, unless you're part of the team that designs the database. A more typical scenario is they give you this database and they go, here, use it, do your work on it, and then so it's up to you to kind of figure out, okay, how is my database? How is it organized? What are the relationships? So on and so forth. All right. Anybody having any trouble at this point? Everybody okay so far? Yes. Yeah. 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 A lot of companies use PHP-MyAdmin. They also use MySQL Workbench as well. Yeah. Those are pretty common tools to use. Internal tools? Internal tools sounds like it's something, I don't know, to me at least, it sounds like it's a tool that they made on their own. Like it's a proprietary, like it's like a very specific to the company. PHP-MyAdmin can be used for any databases. I don't know if internal tool sounds like they made their own version of PHP-MyAdmin, and it's like very specifically tweaked, customized to whatever their company is using for. Yeah. Mm-hmm. All right, what are we doing? Okay, so we got all this together. All right, cool. All right, now that we have it all set up, let's go ahead and open up MySQL Workbench. Okay, I changed back to light mode because dark mode on MySQL Workbench was annoying me, so I changed back. Hopefully your MySQL connection down here is still saved. Remember we created this last week. So if you double click that, it might ask for your password. You might see this warning, and then you just click continue anyway. And then it might ask for your password. If it does, it's the cPanel password. Go ahead and do that. And let me go ahead and close this. Okay, and then you're gonna when it opens, hopefully you see this blank page. It kind of looks there's like a line 1 here, and you can actually type in here. And then on the left side here, you might see like this management thing here. Click on the thing where it says schema, so you can go back and forth. Click on schemas, and you're going to see all your databases over here. I have a lot more than you probably, but you'll see a list of your databases here. Okay, so what we're going to be doing is we're going to be writing some SQL. So we're not we're going to write SQL directly on MySQL Workbench, and what that's going to do is it's going to allow us to interact or pull some data out from our database that lives on the server. Okay, so let's talk. So please get that set up for now. And while you're getting that set up or opened up, I'm going to go ahead and open up some slides today because we have some slides to talk about. Okay, so just like I've talked about, let's talk about SQL real quick while you're opening that up. SQL is short for Structured Query Language, also known as, some people call it Select Query Language. but we call it, or people just say SQL. I just say SQL because it's easier to say. Some people, I've heard the other day, like somebody referred to it as like squirrel because it's just funner to say. Whatever the case, SQL, and it's used by the big giant databases like the Oracle ones and enterprise level ones, or MySQL, MS SQL. A lot of databases use this SQL language to interact with the database, and every database has their own little flavors though, like slightly different syntax things. That's why, for example, last week when we had that issue where I made you delete the keyword visible, it's because of slight difference in between versions and things like that. But anyways, it is a general language, but it is slightly like there's like little syntax differences between the type of database you use. So just watch out for that is all. In our case, we're using MySQL, so it's a little bit I think it's a little bit easier to use. But anyway, again, like I said, like Oracle, if you're using like an enterprise level ginormous database, they might have like a little more proprietary things here and there, but generally everything remains the same. SQL commands aren't case sensitive. Yay! Like we don't have to worry too much about uppercase, lowercase. Although we like to capitalize SQL commands. So let's take a look at what a SQL command or a SQL command looks like. It typically looks something like this. Notice the keyword select is capitalized, the from is capitalized, and everything else is lowercase. So in reality, SQL doesn't care if you lowercase, uppercase, anything, but for our own sake, for our own humanity's sake, I guess, we like to capitalize certain keywords is all. So when you see certain words capitalized, it typically means it's a keyword. So we'll continue to talk about this. So SQL looks something like this. We're going to talk, of course, more about what it looks like, but they typically look like this. They're like very simple statements. You could have multiple lines, and they have to end with a semicolon at the end. Very important here. It's not like in certain languages, if you leave out the semicolon, it's not as big of a deal, right? But SQL really cares about semicolons, so just be aware of that. You could have as many lines as you want. You could the indentation, people like to indent just to format things nicely, but that is kind of loose. So uppercase, white space, everything's loose, but the semicolon is very strict when it comes to SQL commands. SQL commands aren't your typical programming language, so there's not really a full concept of functions or there's very light flavors of it, but there's no you can't make write functions or loops. It's not a very common thing to see. SQL is all about making commands, literally writing commands to grab things from the database. So we're going to be using SQL to grab things from the database, like search things from the database. We can use SQL to add things to the database, so on and so forth. Okay. So the song database that we just imported looks something like this, actually. It's actually a pretty large database with a lot of different tables and relationships. There's customers, there's employees, and all that stuff. But we're going to keep it simple. We're going to, again, just kind of ignore everything else. We're going to just where our focus is going to be on the tracks and some other tables here. So this here. Okay, and if you ever get lost, I also have the diagram on the lecture notes as well. Okay, we're going to be referring to the diagram quite a bit just because it's just easier to see what all the column names are and all that stuff here. Okay, so real quick, these are the tables. I kind of already went over it, but there's the artist table, albums, media types, genres, and then there's also tracks. And they all are, tracks is kind of like a main table. All of the other tables are mapped so that we can, all the other tables have our supplemental information. They are normalized, right? These are all normalized tables. So they all kind of map back to the tracks table here. Okay, all right. So let's start with the most simple command here. It's going to be select. This is probably the most commonly used SQL command here. What select is going to allow us to do, and it kind of sounds like a select, it's going to allow us to select data from the database. And it's very useful because we can select a number of things, and we kind of filter, like think about when you're trying to make a search, we can add filters and so whatnot. So select allows to specifically specify columns, like which columns you want to retrieve from the data. So we'll come back to this, but we can specify which columns we want to show. You could also do asterisk to do just select all columns. And then you can say from what table. We got to specify what table, right? Because you can have like 12 tables when you say what table. And then and you could select from multiple tables as well. And then you could also add something like a where clause, where you could add specific conditions, like where the unit price is greater than 99 cents, for example. Maybe the tracks that are worth more than 99 cents. So you can use where clause to specify which, to kind of filter your results. So these three commands, select, from, and where, go together very commonly to help you search data and filter through data, or filter data to the data that you want. All right, so let's go ahead and, also, oops, I forgot one last thing. Another thing that's useful is order by. If you want to order by specifically, like you want to alphabetize things or reverse alphabetical things, or you want to sort from least to greatest if they're numbers, order by is another great command that goes. So select, from, where, and order by typically go together to help you search and filter through the data from the database. Let's look at that where. The where clause one more time, this where. So this condition. So right now we see the greater than sign here, but there's a lot more where operators. You can do equal to, not equal to is interesting. It's like these two, both signs over there, greater than, less than, greater than, equal to. There's also is null and is not null as well. All right, so let's go and try this out. Oh yes, one thing to note is we use single quotes for strings in SQL. Numbers are just numbers. So let's try this out. The best way to learn SQL is to just try it out, and then the more you do it, it makes a lot more sense. Yes? Yep, it's just saying select all my columns from that table. Yep, so let's go ahead and try that out. Go to open up my SQL Workbench, and we're going to write some SQL here. And we want to write it against, so we want to write this SQL against the song database, not my football database or anything like that. So go ahead and click on schemas, and when you go ahead and search for, or scroll down until you see the song DB, go ahead and right click on the song DB, click on set as default schema. Okay, make sure that's bold. The song DB is bold here so that we can, when we're writing the SQL, we're running the language against that specific database. Right, make sure it's bold. Again, right click and click set as default schema if it's not bolded already. Okay, all right, let's go ahead and try writing some SQL here. For comments, in SQL you do dash dash. You could also do slash slash, I believe. Oh no, you can't. Sorry, dash dash like this. So we're gonna go ahead and display tracks that cost more than 99 cents. Okay, then we're also gonna sort them from shortest to longest in length. Okay, okay, so we're gonna do this piece right here. I think you can do star slash here too. Yeah, you could do star slash or dash dash for comments. Oh, I don't know why it doesn't like my, okay, maybe it doesn't like me putting parentheses there. All right, before I do that, let's go ahead and kind of write basics. So select, right? Select means what columns do I want to select. Let's do star just so I can get everything for right now. Which columns do I want to do? And we're going to select from where? What table? It's going to be the tracks table. Let's go ahead and remember that tracks table was our biggest, where'd it go? The tracks table was like our biggest table. So we're going to do select star from tracks, right? So I want to run this query. If you see on the top here, there's two lightning bolt icons. You want to click on the second lightning bolt icon with the eye on it. What that does is it's going to run just this line, these two lines right here. So it's not going to run our entire code. So I'm going to go ahead and click on that lightning bolt, the second one, click on it. And hopefully you see, oh, interesting, on the bottom, what pops up is all the data that we just searched for. So what it's saying is we're going to select everything, all columns. Again, so select means columns, right? So this is saying select all columns from tracks table. Okay, maybe I should move this over. Okay, this is probably the most simple thing here. So I could just select star from tracks in one line, or I could do multiple lines as well. It's totally up to you. A lot of people like to do a new line for every command, but SQL doesn't care. So one more time, so I have to select from tracks, and I clicked on the little lightning bolt here, and then there you go, there's my results. As you can see, I'm going to scroll this down a little bit. There's two things that are interesting here. The first thing is now it gives us all these results here. And if you're wondering how many results it's going to show up, I think the maximum that MySQL Workbench just gives is 1,000 results. But this table actually has a lot more than 1,000 results. It has like 3,000 some results or something. But it's going to show you the first 1,000 results. So these are 1,000 tracks from our tracks table. You can see, and you can see all of my columns. There's track ID, name, album ID. All these columns are showing up: composer, millisecond, so on and so forth. Yes. What? The database is selected, but
no, it's like so I complete that.
Uh-huh.
Say no database selected.
Oh, on the left, right here, where it says schema, click on the schema tab. Make sure your SongDB is bolded. Is it bolded? And then click on set as default schema right there. Yeah, right click there. Yeah, just to say this is the table the database work. On the very bottom here, you could actually general comment if there's any errors like with your specific SQL command, it's going to show up on the bottom here as well. So that's also useful. I'm going to go ahead and bump up the font size just a tad here. Maybe like 16, 15, just so we can see this better. Oh, I think I have to quit it. Let me come back. Okay, there you go. A little better. Okay. Yes.
How can we just better visualize this data, like through graphs? How can we use SQL to better visualize the data that we get, like graph that everywhere? Do we have to use a different tool?
You would have to use a different tool.
Okay.
Yeah. This is like the default view of most SQL editors. Is you get like a table view. Yeah, if you wanted like a graph view, yeah, you would need to use some expensive tool probably. Yeah. Okay. All right, cool. So we can select all columns here, and this is I'll just put it here. Limit is 1,000. We could, by default. But of course, if you need to run more, you totally can. So you could do select from tracks, right? You could do this with any table. So select from if I wanted to see like my artist table or something, I can do that as well, and then I would see my artist table as well. Let me go ahead and just put this in one line for now, just so we can see it better. Okay. Yes?
So by default, we only select the first 1,000 rows.
Yeah.
But like in execution plan, it says like 3,000 something rows. So is it like it only shows the first 1,000 rows in our result, or it actually select all the rows?
In MySQL Workbench, it will show you only the first 1,000 results.
Yeah, but we are actually selecting all the rows.
I think even in reality, we are selecting only the first 1,000. Yeah,
Oh,
yeah. I think that's a general default for everybody.
Okay.
Yeah. But you can always change that default. Yeah, depending on what tool you're using and all that. Yeah. Okay. So yes. Oh yeah. So these are like two separate lines. I only want to run. I just wanted to see the artist. So I clicked on this. I clicked on the Thunderbolt with the eye on there, and then it's just running this line here. So it's not overwriting anything. I'm running like one line at a time. If you run the whole thing, if I click on this first Thunderbolt, it'll run my entire script. It'll first run that one. I guess it shows me two tabs maybe. Wait, let me close this. Let me try that again. If I click on the Thunderbolt, it just gives me two separate results. But when you're typically writing SQL, you're typically only running one command at a time anyway. So, yes. Nope. You can just run it like this. Oh yeah, you can. You can say it like that. Yeah. You can do that as well. Yeah, but then you just see this. Yeah, you just see it like one giant result here. Yeah, which I mean, yeah, you could do that too. Yeah. Okay. All right, that's our basic one there. So let's try something a little bit more, with a little bit more, with some more specifics here. So we're gonna try that first prompt in the slides. Display tracks that cost more than 99 cents. All right, so let's do the same thing. We're gonna select everything. We're gonna select all my columns. Okay, so the select is important for columns. So we're gonna select my columns. We're gonna select from that tracks table. Okay, tracks table. And then now this is where we're going to start adding some filters, like right where, okay, where we said the tracks cost more than 99 cents. So 99 cents, okay, what was that column called? Unit price. Okay, so we're going to unit price, just like that, exactly like that, where unit price costs more than 0.99. Let's do that first. I'm going to make sure you put the semicolon, click on the second thunderbolt again, or if you like keyboard shortcuts, it's command or control enter. So I could command enter right now, command enter or control enter for Windows. There you go. So now now it's showing from my tracks, it's showing everything bigger than or greater than 99 cents. There's my first 1,000 oh no, there's about 213 rows results, it looks like. Okay, makes sense, right? Where, so that's what that where clause is for. And then it says sort them from shortest to longest in length. When we're working with when we start talking about ordering things, sorting them, that's where that order by clause comes in handy. So let's go ahead and do that. Let's go ahead and do order by. Okay. And order by what columns? We could specify what column. So let's say order by, what did I say? Shortest to longest in length, meaning the length of the song. So that the milliseconds is the column that counts how long the song is. So I'm going to do milliseconds. Put the semicolon here at the end. Okay, so this is one line, one piece of script I'm going to run. Then I'm going to click on the second thunderbolt again, and then it's going to show me order by milliseconds. And by default, it's going to go from shortest to longest. Okay, so the shortest song is, Lost Season 4 trailer is the shortest track. I guess we're counting, I guess this also has not just songs, but other media types as well. Okay. And if you want to go backwards, like reverse, right? Instead of shortest to longest, you want to go the other way. You can. There's also another keyword called descending, or so by default it's ascending. But if you want to go the opposite way, you could do descending, DESC, like that. And if I run it again now, it's going to show me from the longest most. So this is the longest song, occupation, I guess. Longest song all the way to my shortest song. That also cost more than 99 cents, right? So there's a couple filters in here. So when you're searching when you're using some kind of website to search things and filter things, most likely that website is using the SQL command somewhere. Like in somebody or somewhere, someplace wrote some kind of SQL script so that you can filter through things. So this is the code that gets run in a lot of websites. You just can't see it, but behind the scenes, anytime you search something, this command, they're using select, they're using where, order by, a combination of these commands are being used. However, this is a lot of information, right? Which is cool, but sometimes I don't need to see all these information. I don't really need to know all the columns sometimes. So I can also I'm gonna scroll down a little here. I'm gonna say display only track ID, name, milliseconds, and unit price, let's say. Okay, so I don't want to. So we're gonna use the same script here to select from tracks, blah blah blah, all that stuff, right? But instead of selecting all my columns, so asterisk just selects all my columns. Instead of showing all of them, I'm going to specify here a little bit. I'm going to go ahead and put enter there. I'm going to select track ID. Okay, right? The column name is track ID here. Track ID, comma, name, comma, milliseconds, right? Milliseconds, and then comma, and then unit price. There it is, unit price. Okay, so if I run this, click on that again. Now, as you can see, we're still showing the same information. Like the rows are the same. Like we're showing the songs that are or tracks that are greater than 99 cents. We're still sorting by milliseconds, but now we see less columns because of this select row here. So keep that in mind. A lot of times, it's easy to confuse the select statement. But select statement, it's exactly selecting what columns you want to use. If you misspell, one second, if you misspell anything here, it's going to throw a warning probably down here. It's going to say, hey, it doesn't know what column unit price is on the bottom. It's kind of small on my screen, but yeah. Yes? What is that? Why is the name highlighted? Oh, I'm not sure. It's not a foreign key. It could be a keyword. It's not. Oh, no, wait. Yeah, I don't know. I'm not sure. Yeah, maybe it's like a reserved word, but in our case, luckily it's not throwing an error or anything. It's allowing us to still see the column. Okay. Any questions about that? Hopefully it's straightforward so far. Some people love SQL because it's very straightforward. Unlike like CSS, it can be a little weird, right? Sometimes, right? Anyway, yes.
How do you structure these statements so that you don't get really long run times?
How do you structure these statements so that you don't get long run times?
Like if you need a certain amount of data and you don't structure it correctly, you know how the statements work.
I mean, I guess the best way to do that is to ensure that when you are, be very thoughtful when you're like writing these commands, right? Like when you're putting select, maybe don't do select asterisks all the time. Maybe like specify your specific columns. I mean, I guess you just got to follow the best, like try to keep it as simple as possible. And also, tools like MySQL Workbench or PHPMyAdmin, if it runs too long, it does automatically time out a lot of times, and they tell you like, do your thing is too long. You need to do something. Yeah. Yes.
Sometimes check if the name contains a certain string. Like, for example, display all where the word Battlestar is located.
Great, good question, because we're gonna come to that in a second. Yeah. You can actually say like where. So there's gonna be this where clause, right? We're gonna put where. It's a conditional where name equals like Battlestar or something. Yeah. Yes. So I could say like where, right in here, I could say where name not greater than is equal to, let's say, yeah, or, well let me get to that in a second. Okay. One thing I want to show you before we jump into the name is I want to show you this thing just because you see this a lot. We see this in SQL a lot, is we're going to go ahead and let's do one more statement here. We're going to select everything again from tracks, where composer is not, okay, let me go ahead and run this real quick again. Select from tracks. If you notice in my tracks table, or whatever table you look like, sometimes some fields or some rows have a null value. And null is a very specific type. There's a difference between when a row is when a value is null versus when it's empty. So just keep that in mind. Empty meaning it's just empty versus null. So you can actually filter that out too. So if I do like this, where from where composer, I can actually do is not null, and notice how it bolts. So then I could say, then I can run. I could actually say, oh, only give me tracks that don't have a null composer. Okay, you could also do the opposite. You could say is null as well, which is kind of weird, but yes. Okay, there is a difference between a null value versus like just an empty string. So just watch out for that. Yes. When would you use null? I like to always just null things out. I think that's better practice. If there's no composer for this song, for example, you should just null it. But some people just leave it blank. Like it's just more of a matter of style, I guess. Yeah. But I like to just null out things when it doesn't exist. Yeah. All right, let's go to the next one. Yes, the question we just had. What about things like when we want to search for a name? Like I want to look for a song that has the word balls in it, or whatever it is. We can do that as well by using something called the like operator. So it's part of the where clause, and it allows us to search for specific patterns using wildcards. So for example, if I look for where pattern like land and then percentage, it's going to match land and then landmarks and landlord. So any of the words that appear after the word land will show up. The other way around as well, if I put percent land, that means anything that has something before land shows up as well. Or you could say as long as it has the letters land in anywhere, then you can search that way as well. So using this like operator, we can search for specific substrings. Okay, and you can also put spaces as well. So let's try that out as well. Let's go ahead and scroll down here as well. Down. We're going to, and also one more thing before I jump to that. So we can do like operators. With where, you can also combine multiple. So you can say like where this or that, or where media type and that. So this where clause can get pretty extensive depending on how much you want to filter things. Okay. So let's try this out. Let's try this one where we go display, display tracks that have you or they in their names. Okay, so let's go ahead and do our first thing we're going to do. We're going to select all my columns from the table called tracks. Just keep it easy for now, right? And we're going to do where name, okay? And this is where the word like comes in handy. Where the name like, and let's go ahead and do strings here. Let's do the first one, you, let's say. Okay, so any of my tracks that have the words YOU in it, and there can be some words before it or after. Let's go ahead and show that first. There you go. There's a lot of you. There's a lot of songs with the word you in it. Okay. So if I didn't use like, and I could also have used equal sign. But the thing with equal sign is that means it's going to be an exact match. Like they're looking for a song directly called you. I guess there is no song named you. Right? So using that like operator makes it a lot more flexible search here. Yes. It is case sensitive, yes. Or a case insensitive, I mean. So notice how I did YOU, but you see like the capital YOU is everywhere. Yeah. Okay, and then you could continue to build into this where clause. You can say, okay, I have two search patterns I want to look for. It's you or it also has the word day. So you could do where there you go, like that. Where name is, so you got to still specify the column where name like you or name like space here, day. Okay, then you should see, hopefully, that we will see there should be songs that, there you go, there's also songs that have a you or day. So there's like King for a Day, Are You Gonna Be My Girl, Look What You've Done. And then there's like Diversity Day, Valentine's Day, so on and so forth. Alrighty. When you're using multiple clauses, though, you got to watch out for things a little bit because when you have a bunch of ors and ands, you got to remember like order of operations, right? Like which one comes first. So there's some rule of order of operations when you're using multiple where clauses. So you want to watch out for that. So let's go ahead and try this one to give us an example. The next one we're going to do is display tracks that are composed by U2 that have you or they in their names. Okay, so there's a little bit extra information here. So I want to display tracks that are composed by U2. Okay, but they also have the word you or they in their titles. Okay. So same idea. Let's go and start off the same. We're going to select all my columns from the tracks table, right? Okay. So let's kind of take it one by one. So I would say like kind of the same thing, right? Where name like this part sounds like it should be the same, or name. Hello. What's going on? Oh, that should be fine. Oh, I think it's because I didn't close this yet. There, yeah. Okay, just it caught me too early. Or name like. Okay, right. That's what we already have. But then we're gonna add one more thing, right? We want to add and it's also composed by someone along the names of U2. Okay, we're gonna kind of be a little bit loose here. Let's see what happens though. All right, let's go ahead and I'm gonna run the Thunderbolt, second Thunderbolt. Okay, so display tracks that are composed by U2 that have the word you or they in their names. All right, let's take a look. So if you look at the composer, right away we see some issues. I wanted to only look for songs that are composed by U2, but this is not quite right. These composers are obviously not just, it doesn't, I don't see, oh, I see some U2, like at the end, but a lot of these are not composed by U2. And the name here as well, it's like the names, okay, we do see the U in it. Do we see the A's in it? Okay, so something's a little off. Okay, so when you have multiple clauses like this, you got to be a little bit careful here because there is some order of operations. What happens is usually what's going on right now is the word and takes precedence over the they or. Okay, so what's actually kind of happening here is like this. Let me kind of put parentheses where name. This is what's happening. So it's saying it's because and takes precedence. It's saying it's doing this. I'm just putting parentheses around just to show you what's going on. Okay, so this is a search it's actually doing right now because and takes precedence. Okay, think of and as an easy way that I learned to think about and is like a multiplication and or is like a plus sign. So you know how back in your algebra days, order of operations, multiplication goes before addition. So this bit here, it's actually looking for any songs that have the name that have the word you in it, which is correct, or songs that have the word they in it and it's composed by U2. So if you actually scroll down to the U2 composers here, where we go. All of these here, they show up. They all have the word they. Oh no, they also have. Okay. Oh man. Yeah. Oh, I see. Okay. Oh, this has both in it. Interesting. Oh, no. This one has, okay, yeah, that's scary. This one has both composers. So that's why it's showing up, I think. Yeah. Okay. Right, so if I want to fix this, what I want to do is go ahead and delete this over here. Or I can use parentheses to make something more, have precedence over others. So I can do something like this, where name like this, where name like your day, like that. There you go. So I can say no. I'm giving a little more. I'm saying look for any these matches. So they all have to have the composer U2, but then the name itself can have the U or day. So if I run this, there you go. Now great. Now this is correct. All my composers are U2, and now the name has either U or day in it. Yes. Oh, can you have multiple wheres? That's a good question. Why don't we try it out? I don't think you can, but I could always be wrong. Let's try that. So like that, yeah, I don't, let's see what it says. Yeah, I don't think it doesn't look like you can have multiple wheres. Or I mean, maybe, oh, you mean like where name, or where composer. Yeah, it doesn't look like you can. It does. Where is not valid at this position? Yeah, I don't think you can. I think you want to keep going with, although I feel like you could too, but. Yeah. Let's say you can. Yes.
Programming practice, so like go to a new line and then every time you press and or every time you write and or.
Yeah. It's a lot cleaner to write. So you could do something like where you can do like where like this, and then because this is like one clause, and then you could do like and composer like. Yeah, it's cleaner. Alrighty. Next thing we want to talk about is something called join. Alright, so as you can see, Song Database, we have multiple tables. Again, I'm kind of reiterating here. But let's say, like, I want to go get some, like, more information. Right now I'm only showing tracks information, which is great. But eventually, like, I don't want to only see tracks information, right? I also want to get the artist information, or the album information, or media type, genre, so on and so forth, right? And so far, like, how we're reading it right now is all we know is, okay, this track, who's going to write your horse or whatever, the media type ID is 1, and to our eyes, we have no idea what 1 means. It's just an integer right now. Genre ID is 1. I also don't know what that means. And the album ID is somewhere like 232. I also don't know what that means. So eventually, like, so when we're first designing databases, this is great. We want to have foreign keys and all that. But eventually, like, when I want to actually see some real results, I'm going to have to kind of refer to multiple tables, right? So this is where that join clause comes in handy. It allows us to combine records from multiple tables. So it's going to allow us to pull the artist information, pull the genre information, whatever, pull information from other tables so that we can see the entire data in one like results table. So the syntax looks something like this. When we like to call this, we're like joining tables together. Select is still the same. We're selecting columns, and we're gonna. There's usually two tables. We usually join 2 tables at a time. So we're gonna join one table and another table. We're gonna bring them together on whatever is common, and that's gonna allow us to get a result from 2 tables. So it looks something like this, and we'll practice here. But again, select the same from, but let's say I want to join my albums table and my artist table. I would do something like this. And then it's like, where do you want to join it on? On is another important word. It's going to be a column that they both share. So we'll look at it in a second. Quick thing about joins, though, you gotta, we talked about join, but there's also something called left join, also right join. Quick difference here is that when you're joining 2 tables together, think of them as like, it's like an intersection. Where table A, we have to make sure you could join things in 2 different ways. The first way is join and only show the results that they match. Or you can say, you know what, show me all my results, show all the results from table A, and also the results that are similar between B and A. So you could actually choose one or the other, depending on what depending on what you're trying to do. So we'll take a quick look at that as well. Oh, also, now that we're also joining a bunch of tables, another thing that can happen is, well, what if some tables have similar or the same column name, right? For example, in my tracks table, I have a column called album ID, right? But my albums table also has an ID called album ID. And this happens a lot. And if you're not in a position where you can change the column name, you have to deal with it. There could be conflicts, right? They're both album ID. Okay, so if you want to specify, so in order for us to kind of resolve these conflicts, we can actually specify. Maybe you've seen this syntax before, this dot notation. You could actually specify, okay, I want to get tracks from my album ID, and then albums dot notation. I want to get the albums ID from the albums table. So if you've ever seen this syntax before, that's what it means. We can also specify specific tables. We can say table name dot and then column name, table name dot column name, just to for us to differentiate between two. Yes.
If album ID is foreign key, do we still need to?
Yeah, even if it's foreign key. Yeah.
Oh, okay.
Yeah. If you're accessing both tables, yeah. Yes.
If you want to access all the tables, could you do like tracks dot star? But only one.
Oh, tracks dot. That's a good question. Like tracks dot star and then albums ID or something.
Exactly.
Right. That's a good question. I would try that out in a second. Yes.
So this right here is gonna like give you back all the results that would pertain to your conditions in both of those lists.
In both of these tables, yes, it's going to show me all my IDs for both. Yeah. So if albums, if there's 5 albums, I'll see 5 album IDs. If there's 10 tracks, I'll see 10 IDs. Yeah. Just watch out for another way we go. Yes. No, this will return in one tab. This one's not joined. Yeah. It'll just say one column will be album ID. It will show like 5 album ID. Right next to it, the second column will be just the album IDs, like however many there are. So there's actually no relationship between two. Just one table of 2 rows, or 2 columns. Yeah. Good question. Another way we get around like seeing multiple IDs is you could actually alias columns as well. So the keyword for that is right there. If we see the same name for when we get the results back and the columns are named the same, it can be kind of confusing. We like to use this keyword AS for aliasing, and so we can use that as well. So there's aliasing to help us differentiate columns that come back to us versus you could also, if you want to retrieve some things with similar column names or same column names, you could use this dot notation. Okay, so let's try this out. So when we start messing around with multiple tables is when we start to get these name conflicts, right? So let's try this one. We're saying display all albums and artists corresponding to each album. Okay. Only show album title and artist. Before I jump into that, I'm curious, so I'm gonna go ahead and do what we just. So if I did from tracks, just real quick, if I do that, then we see tracks, right? So if I do like so if I do tracks and albums, I can see everything from that. But the question we had earlier was, can you do something like this, and then like albums dot album ID? Like, is this legal? Oh, I guess it is. Yeah, you can do that. Pretty cool. Anyway, all right, let's go now. Let's go back to our original prompt. Display all albums and artists corresponding to each album. Only show table the album artist, and artist name. All right, we're gonna select. Let's keep it simple. We're gonna select everything, and let's take a look at our tape diagram again. So we want to see all of my albums and the artists. So in my albums table, let's look at my albums tables real quick. Okay. Okay, from my albums table is very simple. It just has the title of the album and which artist it belongs to. Okay. But what I want to see is not just numbers. I don't want to see like, oh, artist ID number 1 wrote this album or was involved in this album. I want to see the actual artist name. I want to go grab the name from my artist table, and I want to join it with my albums table from my artists and albums, so I could actually see the name of the artist here. All right, so let's go ahead and do. Kind of do this. We're going to select from albums. Okay, and we're going to join that artist table. Okay, so albums is my primary table. We're gonna bring in my artist table together, and then we need to specify where, like what's the commonality? How are we gonna bring these together? And the commonality between, my artist table and my album table is that artist ID, right? Artist ID is my foreign key. It maps to the artist ID, the primary key here. So that's why I'm gonna say on artist ID, but we need to specify here like which one. So because they're both artist ID, so I'm gonna say where in the albums table artist ID where that matches in my artist ID. Makes sense, right? So we're being very specific here because the columns are both called artist ID. I have to be very specific. I have to say the artist ID from albums table and the artist ID from my artist table. Okay, let's go ahead and join that and see what happens. Alrighty, so now what do we see? Great, now these tables are joined. They have a relationship set. So now I'm seeing, instead of just seeing two tables, I'm actually seeing the mapping between them. I'm seeing, okay, this album, For Those About to Rock, is created by AC/DC. There's our commonality here. So on and so forth. Okay, looks like there's right, and they all map So it's great. So now we know exactly which artist worked on which album. Okay. And I don't need, at this point, now that I have like the exact artist, I don't really need to see the artist ID anymore, right? So I don't need to like this is kind of useless information now. So I can now specify, instead of select everything, I can say select just the title and the name, and then I can see. There you go. Okay. And then this is aliasing comes in kind of handy here, because now what does this column say? This column says title and then name, which is kind of a generic thing, and title is a little bit confusing to name. Like these columns aren't very descriptive. So this is where also aliasing comes in handy. To alias anything, I just write the word keyword as. So if I can rename it whatever I'd like. It's not completely renaming, it's temporary renaming. So I can say, okay, select title, rename it and call it album title, for example. And then name, let's call this one artist name. Okay, now it's a little bit more obvious, like, oh, okay, so album title and then artist name. Any questions about that? Joining. Okay, this is a hopefully you're understanding what's happening again one more time, because joining can get kind of confusing sometimes. But again, for my albums table, I wanted to grab artist information. That's why we joined them together. And the commonality between these two is the artist ID column, right? Because this is the foreign key, this is the primary key. That's why we said on here. Let's try one more example. This one's a little bit more complex. This one is display all jazz tracks. Okay, let's go ahead and try that out. Display all jazz tracks. Okay. All right, let's go ahead and go get my tracks real quick. Okay, there's all my tracks. And jazz is a genre, so we have this genre ID over here. Okay. What I want to do is I want to show only the tracks that are whatever genre ID jazz is. So let's do a quick select from my genres as well, because I don't know what's in my genre table at all. There's, okay, rock, oh, there it is, jazz. So jazz is actually, the genre ID is number 2. Great, okay. And we like to use primary keys when we're working with this, because what if, like, I don't know, I doubt this would ever happen, but what if the word jazz changes? Maybe somebody once says, like, you know what, jazz is no longer, like, the name jazz, it needs to be changed to jazzy or something, right? It won't happen, but just in case that happens, we could change the name here, no problem, but the ID, the primary key would never change. So this is, we're always going to refer to the primary key. All right, so when I say, yes, sir. They reorder it, then they just screwed everybody that's using the database. So they'll get very mad at that person. Yeah, yeah, yeah. That will really suck. Yeah, or more like if you really have to reorder, you just have to let everybody know so that they update their thing. Yeah. So let's go back to my tracks. So now I know that if I do select from tracks where genre ID equals 2, right? Then I know that 2 will be, there you go. These are all jazz tracks now. Okay. Okay. But I have a little bit more extra information here that I need to do. Okay, we're going to display all jazz tracks. Okay, but I have a little more thing I want to do. I want to what did I say? I want to show, sorry. I want to show track name. What else? Genre name, album title, and artist name. So I want a lot more information now than just the jazz track. Okay. So this still is going to be the same. But we're still going to go through my tracks, and I'm going to look for my jazz tracks only. But I also want to show some more information. I want to show the genre name, album title, and all this information. So if I want to show all this extra information, that means I need to go and actually I need to go and join some tables here, right? I need to go and join all these tables here. So let's go ahead and try that out. So we're going to do this from tracks. We're going to do a join on, join. We're going to join, first things first, we're going to join my tracks with genres. Okay. Sometimes we like to do indentation here. Join on. What are we joining on? So genre has a genre ID. Tracks has genre ID, right? This is how they connect to each other. So we're going to do on tracks.genre ID. And the order in here doesn't quite matter. You could do either way, but we just need to specify the column here. Okay, so this order, you could flip this around, but as long as you have the correct column name here. Okay, let's go ahead and try that. Oh, yes, and then we get this error. It's saying like, hey, the genre ID in the where clause, I don't know what you're talking about. Because now that we joined two tables together, right, tracks and genres, it's saying, I don't know which genre ID you're referring to. We got to specify which one we're referring to. We're going to say tracks.genre ID equals 2. Actually, either one's okay. We can use either one, but there you go. Okay, now we're seeing, there you go, there's jazz, as you can see, jazz right here. Okay, so I got my genre name right here. There's a jazz way at the end here, but there we go. Okay, what else? We also want to show album and artist as well. So we can do multiple joins at once. So I'm going to go ahead and join the album as well. And then we're going to join this one on kind of tracks that, there you go, tracks dot, where is it? Album ID? Album ID equals album, I think it's also album ID. Okay. And then it also wants the artist, so we're gonna have to join that as well. Artists on so tracks doesn't have an artist, right? But artist comes from albums, so we do albums dot artist ID. Okay, where tracks dot genre ID equals 2. Whoa, there it is. Okay, that's the full statement here. So as you can see, SQL statements can be short or it can be super long, like this one. Okay, let's go ahead and run this. Holy cow, now we have a lot of information. Artist ID, like name, right? Album ID, so on and so forth. Okay. So I have a bunch of results. It's kind of messy. If I want to kind of clean it up, I would need to, instead of doing select star, I would kind of filter out the ones I want to. Right, like I only want to see, if I want to only see name, like genre name, I will need to replace all of that. But for the sake of time, I'm going to just stop here. But this is probably the most complex SQL statement you'll be writing so far. So you do have a lab that's due tomorrow, as usual. It's not too long. It's just to help you get used to writing some select statements. So you're gonna be doing very similar things in your lab. I'm giving you some prompts, kind of like the prompts we just had. And you're going to write some SQL statements, run it against the database, make sure it works. And then what you're going to be submitting, we're not using FileZilla yet because we're still working with databases. You're going to be submitting this file. Oh, I forgot to save. So you could save this file. Oh my goodness, I can't believe I forgot to save. I can save this script and it saves as a .sql file, right? So let's go ahead and save this in my AM folder here. Lecture 13. Let's call this like select statements something. So you could save this, all the SQL you wrote in one file, and so you could upload this one file into to Blackboard. So that's your lab. All right. Okay. And normally I would give you time to start on the lab right now, but I think you're more interested in getting your midterms back. So let's pause here.